Okay, I'll go ahead and get started if you're okay, co-chairs.
Yeah, it's okay with me. What about Mac?
Yeah, what about him? Should we wait or what do you?
No, I'm sending him a message.
Okay.
Um,
All right, I'll go ahead. Welcome to the MPLS working group session. Today is Friday, the last day in this IETF 109. This is a 2-hour session. I am Tariq, and we have Loa and Nick as co-chairs. Our working group secretary is Mac Chen. He's lost in action right now, but we'll find him next. This is, yeah, probably you've seen this slide multiple times by now. This is the Note 12, which governs the policies of your contributions and attendance or participation in IETF. As usual, if you've not read it or you're not acquainted with it, please do so. The blue sheets, as usual, they're for online meetings. You don't have to sign in. They're automatically collected. The Meet Echo, if you're here, then you have the right URL. Jabber is integrated into Meet Echo, so we'll, I think Nick and Loa will be taking care of any questions that pop up. Minute taking, we have the CodeMD link. Please, if you can contribute to the minute taken, please do so. The agenda is published online, so. And I'll be presenting that in a minute. So take a look. If you have issues, please raise it. Slides are also available for offline taking a look. So here's the agenda. We have 10 items on the agenda. It's a 2-hour session. We think that we will be on time. If you have any issues with this agenda, please raise it. Otherwise, I'll proceed. We ask the presenters, as usual, to stick to the time slot they're assigned. 10 items. In terms of errata, this time we have two reported erratas. Looks like a PDF has corrupted the formatting. There is a, for RFC 6428, the reported issue is with the remote BFD discriminator. The suggestion is to reset it on timeout. Or on the transitioning to the down. I did quote RFC, which I don't have the number now because of the garbling of the text. But the suggestion is that if a period of detection time passes without the receipt of a valid authenticated BFD packet, this discriminator must be set to 0. So this is kind of an agreement. We will take it back with the AD and see how to progress on this errata. Anyone wants to make any comment on this errata, feel free. Okay, I guess no one has an issue. The second errata reported on RFC 6512. It's a typo. Since P1 has no root, should be since P1 has no route. Again, this is a simple typo. In terms of liaisons, we have received one liaison in response to a previous liaison with OTNT. It's an ITU research group. And you will see that there is a response from, actually this is a response, this is from Mpls to ITU. and there is a response back from ITU to MPLS on the same matter. We have another separate liaison from ITU to MPLS about MPLS TP documents for information. So if you go to the link, you will see all the documents that that this liaison is all about. Co-chairs, feel free to add if I'm missing something. Okay.
Can you hear me?
Yes, yeah. I can hear you.
Yeah, okay. Oh, but I think we should actually thank Scott Mansfield. He's doing most of the work, putting the liaisons together on our side and make sure that they actually respond on time. So he's doing a very good job. And please, if he wants support on anyone in the working group, please help him. That's okay.
Okay. Thank you, Loa. I'll move on to the document status. So we've not had any new RFCs since IETF 108, but we do have three drafts or documents that are in RFC editor queue, and they will become RFCs soon. We do have one document in IESG. It was expired, but the authors this week, they have refreshed the document. There are some outstanding IESG review comments that are being worked on. This is the feedback I got from the authors on this one. There are no new working group documents that were adopted, although we have received a number of requests for working group adoption, and we will see that we're taking action on those. In terms of working group, updated working group documents, we have the MPLS static Yang. It was updated, and this was waiting on the base MPLS base Yang, which is now in mature state. It's going to become RFC soon. So this will progress quicker now, given the dependency is also almost complete. The second draft here, the RMR MPLS, is a little bit controversial. This was in IESG and it was returned back to the working group. We were discussing it just before we started the session. Loa might have some words to say about it, and we expect some update from the chairs on this. I will stop here and ask if Loa wants to add anything on this document.
Not anything substantial. I think the true statement at the moment is that we have not finished the discussion among the chairs, what we actually want to do. It will take a couple of days next week, and then we will send out a statement either from work group chairs or from the shepherd. Thank you.
Okay, thank you. The next updated working group document of interest, we have the MPLS BFD directed. This is also controversial. It's been lingering for a while, but we have a follow-up with a meeting with the authors and reviewer Carlos underway. So my understanding is Nick is arranging that. I will pause here again and ask if Nick wants to add anything. Nick?
Set up a meeting, yeah.
That's it? Okay. The next one here, the LSP ping registries update. It is in working group last call at the moment. Recently expired documents, they are working group documents. So the first one is RMR. It has an RMR dependency on the base RMR draft, and this is the one that we are going to make a decision on soon, and the decision will reflect on this expired document. We have the LSP ping OSP v3 quote point. We have emailed the authors notifying them that this expired, and we have a progress update towards the end. I'll also expand on that. Before I flip to the next slide, feel free to interrupt or add if there's anything from the authors on these drafts. Okay. Any new individual documents? We have one by LOA about the structure of IANA registries in MPLS. So this is an interesting document to organize the code point structure in IANA. There are some issues that were raised by the IANA people that tools do not support the proposed structure. So I understand that LOA, you will be following up with the IANA people on what can be done. And I will pause here if you want to add anything on that. Feel free to jump on the mic.
I can just say that I sent the draft to IANA at the same time as I first posted it. And that was actually the day before the cutoff, so there was not much time. I got the response from Amanda, and Amanda's point is that she likes what we want to do, but the current tools are not supporting one more hierarchical level in registers. And I'm going to talk to both tool people and IANA people and see what we can do.
Okay. Thank you. Moving on, the drafts colored in blue are on the agenda, so I'll skip over those. They will be presented today. That's it. Updated individual documents. We have the LSP ping generic SID. This was presented multiple times, and we received from the authors a request for adoption. These two documents, the egress TLV for NILFEC as well as this one, they seem to be related. The chairs have discussed this, and we're going to ask for the authors' coordination, or at least discussing potential duplication there, and getting reciprocating back on what comes out of it. And based on that, we will proceed with a request with adoption. The second draft here is also, it was also notified that it's ready for adoption, and we have initiated an MPLS review from the team, and the ETA for that is December 7th. The rest, we have two drafts on the agenda, and other ones, there's not much happening on them. Again, the alive individual documents without update. We have one which is on the agenda. The rest of them are, for now, they are not actively being worked on.
Tarek, that is a truth with a couple of things we need to say. When we talked about it, I forgot about it. But all the SFL drafts are requested to be progressed by the authors to the next stage. So that means that you have documents that should go both to working group last call and documents that should go to working group adoption. So we have a mail from the author.
Okay, that's good. Thank you. Yeah, we have one document here for SFL, at least. I see it.
Yeah.
The other one is adopted, my understanding. So that's the one that still needs to be adopted. Okay. Anything else you want to add?
Are you taking queue requests yet?
We will. It has been a little bit, well, my heat has been too big. I haven't really been able to dig down to it, but we are almost there. And I think I will shepherd all the SFL documents.
Okay, I'll progress in the interest of time. I do have 15 minutes. Yes, please.
Tarek, I don't know if you've noticed, you have 4 people with their hands raised in the queue.
I honestly didn't notice because I can't, but thank you for noting that down. Stuart, do you still want to comment on?
I only to understand when the chairs are going to get round to doing doing the last 2 SFL documents, because they have been in this state pretty well since the last IETF.
Loa, you want me to take?
No, I think it's 1 or 2 weeks from now. We need to clean up a bit next week after the meeting, and then we go on to do that. They are next in line.
Thank you.
All right. Anybody? I know that there's someone else in the queue.
Yeah.
Please go ahead.
I don't see
Kiriti?
anyone in
It's
I see Kiriti and
Shedder Greg in the queue.
Kiriti, you want to go ahead?
Yeah, I had a couple of comments about LRP as well as the NFFRR. So we are working on LRP in terms of filling in some of the things that we said we'd work on, but we haven't yet, which is how do you do restart, how do you make it more robust, and a few other things like that. And for the NFFRR, we had made a request for an early allocation of a code point. And I think the response was we should make it a working group document first. We tried to update the document to reflect some of the discussions that have been on the list. The question is, what else do we need to do?
That's a good question. So there is a process that Mpls working group does for adoption. We do ask for a review from 2 of the reviewer teams, and that usually takes another 2 weeks. So based on your request, I expect, Kiriti, that we will initiate that review, and it will get into the process of being adopted.
Okay, thank you.
Thanks.
And we'll come back with.
How big is the NFFRR document?
How big in terms of
pages?
Pages, it's 8-10 pages.
Okay. How important is the early allocation? Are there actually implementations going on?
Yes, we do have a prototype implementation. And you know, it involves doing stuff in microcode, so you know, it's not something that if we went into production, we'd like to know that that's the one that we're going to use. So it's yeah, I mean, there's a prototype implementation. Beyond that, we'd like to make it real, because especially in the EVPN use case, there are issues when the CE dies. You get a loop.
Okay, I will look at the document and see what they can do. Maybe we can expedite the working group adoption, which means that the working group chairs read and say that it's okay.
Yeah, okay.
And not doing an Mpls RT review in that case. So.
Okay. Thank you.
All right.
Okay, and I'll come back to you on LR with an update.
Thank you, Kiriti.
Right,
anyone else in the queue, Noah or Nick?
Yeah, next is Shraddha.
Okay, Shraddha, go ahead.
Yeah, hello. So I wanted to just give an update on draft Winton MPLS string inter-domain OAM. I just posted an update last night. So the 4 points that the registry that we were using for some of the sub TLVs was pointing to another draft in IDR working group, and Nova had a comment that it's better to have a separate registry created for sub TLVs, and I've done that update and posted the latest version. And I think that it's ready for an adoption call. Chairs can look into it and take a decision.
Okay, thank you.
Another update on another draft, which is a working group draft IETF MPLS EPOAM. So this was adopted
Wait,
last
Shadra.
time. And hello.
I think we have that later on the agenda, don't we?
Yeah, we have
No,
a
we don't have it on the agenda.
we have a progress update on working group documents. Still, I haven't
Okay.
gone through. So
Okay.
hold your thought until then.
Yeah,
But
sure.
thank you, sir. Thank you. Anyone else in the queue?
Yeah, last one is Greg.
Greg, go ahead.
Not confused, but what I see in a data tracker on MPLS point to multi-point BFD is that it's marked as a candidate for working group adoption. So
Okay, we'll have to see how it. Co-chairs, are you aware of this being progressed?
Which document is it?
the one that I will be presenting later today.
Okay.
Update to.
So, Greg and everyone else, there is just one point, one way of actually getting a document into the working group, and it is making it a document for candidate for working group adoption. So when we start doing things like reviews and talking to the authors and suggesting things, we need to put it in the candidate status.
That's what I see currently in the data tracker.
Yeah.
Candidate for working group adoption.
Yes, you should see that.
Okay, good. Okay.
The next thing is actually we will start the adoption poll. That's when the states change. So when we say if this document is for any working group within IETF, it is for MPLS, then we mark it as candidate. And that means that we can work with it. Otherwise, we can't do anything.
Right. Okay, thank you.
Okay.
So that's it from the queue.
Okay, thank you. I'll move on to the progress reports. So these are working group documents that are active. The first one is SPL terminology. The current revision is 4. The working group last call is issued for this. ETA is 2 weeks from now. The second one is MPLS static Yang, and it has the next steps of addressing any outstanding comments from the Yang doctors review and adding a JSON instance of the data model, and then we'll proceed to working group last call. The third one is MLDP Yang. The current revision is 7. It is in Yang doctors review, but I heard from the authors that there are no outstanding issues, at least from the review of Yang doctors that was done, and they're ready for progressing it to working group last call. So this is also in the queue for being working group last call. I'll move on to the next slide, unless there are someone in the queue. The MPLS BFD directed, its current revision is 14. We already mentioned that the chairs are coordinating a meeting with between authors and the reviewers to converge on this one. The RMR, we already talked about a decision that the chairs have to make about this, the status of this document. And the next one is dependent on the base RMR, and it's going to be affected by the decision that we will make on that. I presume no one is in the queue because I wasn't interrupted.
I have one small comment.
Yes.
So we also have an RMR TIS document, and it also dependent on the base document. So we need to coordinate with the TIS working group chairs, and they need to follow what we're doing.
Yeah, good point. I agree. Okay. The OSPF v3 code points, this one we already mentioned likely that it is expired, and we're asking the authors to refresh, and the early allocation of the code points will only progress on an active document. The MPLS-SR EPEOAM, it was recently adopted by the working group, and the working group is invited to give comments and review.
I have one quick question. Do we have any author of the MPLS LSP ping OSPF v3 code point in the meeting? If we have, please update.
Okay, do we see anyone in the queue?
Can you hear me?
Yes.
Yes.
Yeah, it's Nagendra. I'm working on updating this. I circulated the updated one just to get a confirmation from the co-authors. By today or tomorrow, we'll be updating the new version.
Okay, thanks.
Okay. I think this is the last slide I have here. The LSP ping registries update. It is in working group last call. There are some outstanding comments. We are requesting the working group to review this document and provide feedback. This is an open invitation to give feedback on this document. The last one is an SFL document. I heard Stuart raise concerns. It is ready for working group last call, and the chairs need to trigger the WGLC, the working group last call. And we have to do that right after meeting this session. Yeah. With this, I conclude my progress report. Before I switch to the first.
I have a question for Stuart. Are there any dependents? No, that because there is no dependence. I mean, should I take the RFC 6374 SFL first, or should I try to adopt the individual draft first? Or can I do it in any order?
There is a reference, as I recall, from 6374 to the control draft. I can't remember whether I left it in or not, but I believe there's a reference. So you probably should take the two. I mean, they're both as far along as they're going to be until the working group gives me input.
Okay. The point is that it takes a little bit longer to get the adoption poll than it takes to get the working group last call. Can I, without any serious problems, start the working group last call now?
Yes. Yeah. There is no reason not to do the working group last call now.
Okay. Good. Thanks.
Okay. Anyone else in the queue? No. Okay. The next on our agenda is Rakesh, I believe, and It's about MPLS data plane encapsulation for NC2AM. Rakesh, are you there?
Yeah, I'm here. You hear me?
Yeah.
Yes,
Now.
you can hear. I'll go on mute and
Yeah. Hi, everyone. My name is Rakesh Gandhi, and I'm presenting the MPLS data plane encapsulation draft for IOAM on behalf of the authors listed. And next slide, please. So agenda is we'll take a look at the requirements and scope, the history and updates since the last IETF, and the summary as well as next steps. Next slide, please. So the requirement is to transport the IOAM data fields with MPLS encapsulation, and IOAM has OAM information like timestamps and many other fields that's defined in the IPPM working group. There are 3 drafts that listed here being worked on. So this is the scope, and edge to edge as well as hop by hop IOAM is in the scope. Next slide, please. So the draft has been around for a couple of years. It was in spring and was transferred to MPLS working group about a year ago. This was presented at the last IETF, and we'll focus on the delta since the last meeting. Next slide, please. So there are a few changes, updates made based on the review comments received since last IETF. This protocol type field is 0010. There is a text that explains why different labels used for the hop by hop and edge by edge, basically to optimize the processing on transit nodes. There is text added for the MSD consideration. The diagrams or the headers is updated to show the extension label, and few editorial changes. There is no open items at this point. Next slide, please. So just to recap, the MPLS header, it contains the extension label as well as the indicator label that says that there is IOM data populated underneath. Next slide, please. And similarly, there is a variant of it that includes the this IOM flow indicator label, as well as the protocol type and the flow label and block number. Next slide, please. So we are requesting for edge-to-edge case 2 extended special purpose labels for the indicator labels. In a variant, it could be allocated by controller or signal, but prefer the INI allocation values as well. Next slide, please. And the same case for the hop by hop. So there are 2 labels requested from INI as well. Next slide, please. So we welcome your comments and suggestions. Many thanks to all the review comments that we have received. We are requesting a working group adoption for this draft. Since the base work is done in IPPM working group, we plan to keep them in the loop out the progress for this work. So that's all I had. Thanks.
in the queue. Greg, you want to go ahead?
Presentation. Can you again explain their interpretation of 2 extended special purpose labels?
Maybe I missed the question. Could you please repeat, Greg?
Yes. So what's the interpretation? Why are two special labels being requested for each use case?
So those are indicator label, right? So when the header processes, just like entropy label, label indicator label, that ALI, ELs kind of thing. So it when you're processing, it tells you that there is an IOM data field, and then it can be used to trigger the IOM processing. So you activate it.
Right, but for entropy label indication, we're using just one entropy special purpose label. So,
Yeah, so if you go to the figure, if you go back, Tarek, on slide number 7, please.
Yeah.
Yeah, so if you don't have this protocol type 0010, if a transit node does ECMP hashing using the IP header, it could, if the value happens to be 00, for IPv4 or IPv6 case, it might think that there is IP address there, and it could do incorrect hashing. So this is to fix that hashing issue. It's not mandatory, but if there is a customer who has IP-based hashing and need this, then we recommend to use this indicator label with 0010 so that the hashing is not broken.
Okay, but again, here on the figure, so you have extension label and then the special purpose label, or extended special purpose label. So two labels are a special extended special purpose label. But if I understand correctly, so you mentioned that you request allocation of two extended special purpose labels. So
Yeah,
I don't see where the second, the other one would be used.
So if you go to the slide number 6, previous slide. So this is an indicator label. So this is without the protocol type field. And the next one was with the protocol type field and the flow label. So there is a variant to it. So there are two different formats. That's why there are two label values.
Yeah, I wonder if we can reduce it just to one use case, just to make it more, make it simpler.
Yeah, I'm fine with it, but we added the second use case based on the review comments, and the working group had raised this issue. That's why it's there.
Well, I think that if we want to have a general backward compatible case, then use their case on slide 7, and we have one extended special purpose label. Wouldn't it make sense?
Yeah, if working group is okay with that, yeah, I mean, no issue from that point of view. It's just you adding one more label in the stack, and there is MSD consideration and all that stuff, right? So it is fine if working group says we are okay with the slide number 7 indicator label. That's fine as well.
Yeah. Okay. I think that's something to discuss. Because just make it simpler, less options, always good. Okay. Thank you.
Yeah, thank you. And yeah, we can have email discussion, and if the working group has consensus to just go with that, no issue.
Okay. Anyone else in the queue? I don't think so.
Yeah, I think that since this is individual draft, it's for authors to decide where they want to go.
All right. Okay, thank you, Rakesh. I'll move on to the next slot. We have LSP ping for SR path SIDS. Xiao, you're presenting. You're up. Xiao, you're able. Can you try your audio? Hi, Xiao. Can you still hear me?
I do, yes.
Okay, it went that silent. I think Xiao was having some technical issues.
Yeah, and now he's gone. Hang on. Let's see.
Okay, I tried again. Can you hear me?
Yes,
Yeah.
I can.
Gary?
Yeah, that works.
Great.
Okay, good. Thank you.
All right, I'll flip to your slides, and please go ahead.
Okay. Hello, everyone. It's Xiaoming speaking here. This presentation is on LSP ping for SR pass seat. This is a 00 version draft. Next slide, please. Okay, this draft is straightforward. It provides target fact stack TOV definitions for pass segment ID. Specifically, two new sub-TOVs are defined. They are called SR candidate pass SID sub-TOV and SR segment list pass SID sub-TOV. At the same time, this draft augments the SP ping for SR procedures defined in RFC 8287 to make the procedures complete when the pinned object is pass seed. Next slide, please. This slide illustrates the principle of pass segment with Mpls data plane. Pass segment is a type of SR segment. Pass segment with Mpls data plane is defined in Spring working group draft, Spring Mpls pass segment. The pass segment label would immediately follow the forwarding labels. And it's normally used by the egress nodes for pass identification. Next slide, please. About pass segment allocation, as described in the working group draft Spring Mpls pass segment, there are several ways for allocating the pass segment to the ingress node. The first way, pass segment is allocated by the egress node through a communication channel between the egress node and the ingress node. Currently, the details of this way are for further study. In other words, till now, there is no proposed protocol for allocating pass segment to the ingress node by the egress node. The second way, pass segment can be allocated by the centralized controller using PSAP. There are already working group drafts on this way. The third way, pass segment can be allocated by a centralized controller using BGP SR policy. There are also working group drafts on this way. The fourth way, pass segment can be allocated by a centralized controller via configuration. There's already a working group draft on SR policy YAM model. Also, as described in working group draft Spring Mpls pass segment, if pass segment is allocated by a centralized controller, then the controller must make sure that the egress node knows the path segment and it can process it. Next slide, please. This figure defines the format of SR candidate pass SID sub-TOV. As specified in working group draft IDR SR policy pass segment. The path segment can be used to identify an SR candidate path. That's why this sub-TOV is defined for SPP. As specified in working group draft Spring segment routing policy, an SR candidate path can be identified through the tuple, head end, color, endpoint, protocol originator, and discriminator. So these tuple fields are specified as the validation keys of this sub-TOV. Next slide, please. This figure defines the format of SR segment list path SID sub-TOV. As specified in working group draft IDR SR policy path segment. The path segment can be used to identify an SR path that's defined, specified by a seed list. That's why this sub-TOV is defined for SVP. As specified in working group draft Spring segment routing policy and individual draft LP IDR SR path protection. An SR path can be identified through the tuple head end, color, endpoint, protocol originator, discriminator, and segment list ID. So these tuple fields are specified as the validation keys of this sub-TOV. Next slide, please. Path seed fact validation procedures are augmented to the fact validation procedures defined in RFC 8287. When the target fact stack sub-TOV is SR candidate path SID sub-TOV, the receiving node would firstly check the basic length of the received sub-TOV, and then secondly validate that the path segment ID is signaled or provisioned for the SR candidate path. When the received protocol origin field is 10, which means PSAP, the receiving node would validate that the path ID path seed matches with the PSAP tuple, identifying the SR candidate path. When the receiving protocol origin field is 20, which means BGP SR policy, the receiving node would validate that the path seed match with the BGP tunnel, or BGP tuple, identifying the SR candidate path. When the receiving protocol origin field is 30, which means Y configuration, the receiving node would validate that the path seed match with the YAN tuple, identifying the SR candidate path. Next slide, please. So the procedures to check and validate the received SR segment list path seed sub-TOV are similar with the last one. And the only difference is that this TOV includes one more validation key than the previous sub-TOV. That's called segment list ID. Next slide, please. Here we list some considerations we have in mind when writing this draft. The first one, currently it seems there is no protocol on allocating path seed by the egress node. If it's brought up later, then new target FAQ might be defined. The second one, currently it seems there's no PSAP details on allocating pass seed to identify an SR segment list, which is outside the scope of this draft. Because this draft is just for extending SVP to validate the control plane to data plane synchronization for pass seed. The third one, currently it seems there's no young details on allocating pass seed, which is also outside the scope of this draft. The fourth one, currently ISP trace route is mentioned in this draft. However, the use case for pass seed trace route is still unclear to the authors. And whether it's really needed is for further study. Next slide, please. So next steps, we ask for more reviews and comments. We'll revise this draft to resolve the received comments. And then at some point, we may ask for working group adoption. That's all.
Thank you. Anyone in the queue? Nick, Loa?
Yes, Xiang?
So 2 questions. First, like the pass set is a list of labels. So like how do we align fact stack with label stack and do a fact stack change procedure? So the second question is we might need a type field in the sub-TLV to define to separate the TLV type for IPv4 and IPv6 types. So basically in TLV format, like we shall not use error information for the purpose of T. So use sub-TLV length to derive the type is not a good practice and not flexible for future modification. So it's better to align with other RFC drafts in this area, like RFC 8287, RFC 829. And so in both cases, IPv4 and IPv6 either use 2 types or use a type field to element ambiguous. So yeah, that's it.
Okay, thank you. So your first question is about alignment between label stack and FAC, right?
Yes.
So this FAC sub2v is taken within the pin package. So I don't know whether we need to align.
So the problem is like in RFC 829, so it defined that basically the label stack and the number of related items in these 2 specs should match. So how do we match these numbers? Because like the pass segment will like populate a list of labels, but here we just use 1 fact type. Like do we like push more facts to extend the label?
Okay, I understand it. I need to check that obviously 8029. So I will give you a response maybe by email.
Thanks.
Thank you.
Zafar, go ahead. Zafar?
Yes, can you hear me?
Yeah. Yes.
Okay, very good. Okay, so basically there is a draft that is on the agenda as well, and I like to point out, because this is a good example of some complexity that comes in Mpls ONM machine. The draft that I'm referring to is one that Nagendra is going to present, is on the SR generic label sub-TLV. The idea is to simplify this and not to make it more complex and keep chasing, as we define new and new SID type, keep chasing a definition of FAC, but really extend a notion similar to the nil FAC and add some egress validation associated with it. So I would like that you take a look at that draft as well, and then see how it actually works for your use case. And if we can, I mean, we can work a little bit more offline as well, talk a little bit more offline to explain and discuss. But I think we can do a simplification using the SR generic label sub TLV.
Thank you, Java. I know that's a draft by Kuma. I think these two methods are complementary to each other, because using just one SR label, it can validate some portion of the scope, but it cannot be used to validate the synchronization between data plane and the control plane. So I think this draft maybe is also needed. They are not in conflict.
So and that's the main thing, is that the synchronization between control plane and data plane is a goal that MPLS ONM machinery started with, but it has a large cost for deployments. As service provider deploy new technologies, ONM is starting to become behind, and there are some challenges. So I think just for that, and just chasing that role for defining a new fact type, I'm personally don't like that. But anyway, I think we should talk a little bit more and then see, at least for the data plane validity, how can you use the SR generic label sub TLV for the path segment use case?
Okay, we can discuss it offline.
Thank you.
Okay.
Thank you.
Mac, go ahead.
Question about so what's the purpose of to validate the path segment?
That's a good question. I was going to ask it. Okay, I'll remove my hand.
The purpose is to check whether the path segment allocated to the ingress node can be forwarded to the correct egress node. The egress node can check whether it's the right path segment, is the correct path segment that's allocated to the ingress node. So that's the intention of this job.
But then you can allocate it per policy, right? Why per candidate path and per segment list?
Because there is a working group draft in IDR working group, I think, for IDR path segment. In that draft, path segment can be used to identify the two different things. One thing is SR candidate path. The other thing is SR path specified by seed list. So we followed that definition and defined the two sub-TUVs for the two different things.
Okay, I assume Zafar, Mac, you already out of the queue. Xiang? Xiang, do you want to go ahead?
For the purpose of this, so because of we don't have data path validation, so this is a pure control plane egress kind of audit. So why we not do it in control plane protocol instead of doing in OM?
Control? Do you mean control plane validation?
Yeah, because I don't see any data path validation part, so we cannot validate control plane between control plane and the data path. So because the label stack cannot be validated in the header, right? So you go back to the fact.
Oh, I understand.
Stack.
I understand it.
Yes.
Yeah, maybe there is also other method to validate this. we'll see. Yeah.
All right, Cheng, can you make it quick, please? We're over time.
Okay. Welcome to join the post-second work. And luckily, I have the order of the BGP policy drafts, and I think it's valuable to do something associated with to pod segment. But I don't really think the mechanism is valid right now. I'll take some time to read it. Thank you.
Thank you. Thank you.
All right. Okay, thanks. I'll switch over to the next presentation in the interest of time.
Okay,
Greg,
thank you.
Greg, thank you. Thank you. And Greg, you're up next.
Okay, great. Next slide, please.
All right.
Okay, so this is an update to our draft on point-to-multipoint BFD applicability to Mpls LSP. And so we have two new experts joining the work. Welcome, Donald and Guyan. And so to recap the motivation that point-to-multipoint MPLS LSPs are being used and will be used. So their issue is that RFC 5884 that defined only point-to-multipoint BFD applicability to MPLS LSP. Recently, two RFCs been published by BFD working group. It's RFC 8562 for BFD for multipoint networks and 8563 BFD for multipoint networks with active tails. I believe that the latter one, the active tails, is more interesting because it allows the root to learn of their state of their multicast distribution tree from their point of view of the tail. Next. Yes, and to mention that seamless BFD seems not to be, at least now, defined how it works over multi-point, multi-cast networks. Because point-to-multipoint BFD uses demand mode and there is no three-way handshake, it requires bootstrapping. The bootstrapping that we propose could be using the periodic LSP ping. So if a new tail joins the multicast distribution tree, then the next LSP ping will bootstrap the session. There are some changes to the process of bootstrapping as defined in RFC 5884. So because their head end is not interested in a discriminator, and actually the tail does not allocate one for the BFD session, so we recommend to use do not reply mode for the LSP ping that includes BFD discriminator. Also, their point-to-multipoint BFD session over MPLS LSP can be bootstrapped using BGP BFD attribute that is defined in BAS document on NVPN fast failover. So what changed? Historically, for IP UDP encapsulated in IP UDP encapsulated OEM packets under MPLS, we used to use IPv4 loopback range, or recommend to use any address from that range. And then for IPv6, IPv4 mapped addresses. So basically the same addresses mapped into IPv6. What is interesting that in IPv6, this address range doesn't have any special meaning. So it's not the loopback addresses. And I was demonstrated that available IPv6 stack will generate a ping to any of these addresses. So it was recommended that to use the only loopback address that is defined for IPv6 in RFC 4291, address 1/128 is the only loopback for IPv6. And since we're using one address for IPv6, it would be logical to use one address for IPv4 encapsulation, IPUDP encapsulation of OEM packets. So in this specification, we're proposing to use 127.001/32 and 1/128 for IPv6 as destination IP addresses using IPUDP encapsulation. The UDP port would be as for single hub BFD 3784. And the source port number will be in a dynamic range of port numbers. Okay, next slide, please. RFC 8563 defines three types of head notification. The multicast polling, the composite polling, which combines multicast polling using their multicast distribution tree, and then unicast polling using paths that are not using the same links as a multicast distribution tree. And the third option, but not defined, but mentioned in the RFC is head notification without polling. So in this draft, we provide more detailed explanation of the mechanics and how head notification without polling operates. So basically, it's unsolicited event triggered option. Next slide, please.
If you can wrap it up.
Yep.
3 more.
So this diagram just presents their mechanics as that we have a P1 that is a head end and P4, 5, and 6 as a tails. And if network failure occurs, then the tails will generate unicast poll to the head end, and head end will send the unicast final and then can take corrective actions. Next slide, please. So we welcome comments, suggestions, and questions about the proposed solution. And as I've mentioned in the discussion earlier, I really appreciate that this document being put as a candidate for working group adoption. Thank you.
Thank you, Greg. Anyone in the queue?
No, the queue is empty.
Right.
Okay, thanks.
Thank you, Greg. Next up, we have, I think it's Deepti or Shraddha. We have egress TLV nil for NILFEC. Is someone coming up to the mic?
Hello, am I audible?
Yes, you are. Go ahead.
Hi, I am Deepti, and along with the authors, we are presenting egress TLV for the NILFEC as extension to the NILFEC. Next slide, please. So in this slides, we will be touching the Spring T requirement for the OM and how NILFEC fits in that picture, and egress TLV, how it completes the how it completes the whole OM requirement with the example. Next slide, please.
Sure.
The SRT paths are built by stacking the labels that represents the nodes and links in the using the adjacency set, node set, and all this. This give requirement. So the basic OM is not basically hop by hop basis, which give rise to a ping and trace route for these paths. Now the idea to verify these label stack by sending the MPLS echo request packet with entire label stack along with the same data along on the same data plane as used by the data traffic. In certain use cases where the SRT paths are built by controller, the head-end routers may not have the complete database of the network or may not be aware of the FEC associated with the labels that are used in the label stack, like static LSP labels and others. There is another use case where the router in the network are not upgraded to support the FEC validation for the SRT paths. This nature of the SRT paths raises additional consideration for fault detection and isolation. It is useful. It is useful to have the ability to traverse the paths using ping and trace route without having to obtain the FEC for each label. Next slide, please. RFC 8029 support this mechanism using NIL-FEC. Now NIL-FEC, as outermost FEC of target stack is the NIL-FEC, then the node skip the target FEC validation and goes directly for the label stack validation. So we can always build an intelligent application which will help to validate, do the extra additional verification on the ingress for the using the data sent by the transit node to verify the data plane, data forwarding plane is same as the label stack path provided. This also helps us to verify the backup paths before using it as a primary path. So, since the NIL-FEC carries only label information and no FEC related information, it may happen that that there is a high possibility that the packet may be misforwarded to incorrect destination, even though the ping and trace route returns success. There is another thing when router in the label stack path receives MPLS echo request, there is no definite way to decide on whether it's egress or transit, and it solely depends on the receive label stack. Thus, to use NIL-FEC in the for the SRT paths where FEC validation is not possible, we should have additional information regarding egress so that the egress validation can be completed. So if with the help of the egress information, it will help to determine if the receiving router is egress or transit, and it will additionally ensure that the packet is received on the correct destination as destined by the label path. Next slide, please. So this is where the egress TLV come into picture. So this is a very simple TLV which has the endpoint, the SRT path endpoint as a prefix inserted in it. So even if we have multiple NIL-FEC, the last NIL-FEC endpoint will be the prefix used in the egress TLV. Now, how it helps in determining the egress validation is as NIL-FEC, as in RFC 8029, if the outermost FEC is NIL-FEC, all the transit node will avoid to do the FEC validation. So the label stack will use to forward the packet. At the last neighbor, when the label stack is like reached to the last label, last router, there it will check for the egress TLV and the prefix is matching with the any of the interface IP addresses or the local loopback address, and thus determine that is the egress for this path or not. In case if it is failed to match with the any of the interface IP address, it will send a failure saying that it is a non-compliant or no mapping is present. Next slide, please. So this is the example where I'm taking like a SRT route with the label stack provided. It has 4 segments. Next slide. So this is the trace route path as per the previous image: R1, R2, R4, R5, R6, R7. So the destination, as per the label stack, the destination endpoint is R7, and we are starting a trace route from R1. So the behavior on R2, R4, R5, R6 is given in the next slides. Next slide, please. So when the request is going, it will send the egress TLV will be added as given in the slide with the endpoint of the SRT path. The verification on all the nodes will happen based on the NILFEC. Next slide. So all in the advantage of adding a NIL like a egress TLV is none of the in-between routers like transit router need to be upgraded to accommodate the egress TLV, as it is optional, and on the transit router we are not checking for the egress TLV. So it helps to have the backward compatibility. So on each router, we will be checking based on the label stack provided, and it will behave, the behavior will be same as given by the NILFEC in RFC 8029. Next slide, please. We can go to the next slide at the end of the slide. Yeah. Next slide. So here, once on R7, when the label stack reaches to the last label, it will go and verify for the egress TLV. If it matches with the interface on any of the IP address on the R7, with so it will return with the thing key it is a egress for this label stack, and thus the egress validation can be achieved using the NILFEC. Next slide, please. We request the reviews and comments on this along with like working group adoption.
Okay, thank you. Anyone in the queue?
Yeah, we have 2 people in the queue. Xiang?
Yes, so a couple questions here. So as like work group chair already mentioned, this has a confliction with the like SR generic TLV. So another thing is, I assume this solution is for prefixed only. So if it's for IPv4 or IPv6 prefix, so why may not use existing generic IPv4 prefix sub TLV that has been there for many years? Yeah, okay.
No, you can complete the question.
And how we handle adjacency set? So if the last segment is not a prefix set, and so for binding set, these kind of set are like upstream router assigned or popped labels. So how do like egress for this? So another thing is like I noticed that you have 2 TLVs in the FAQ. So one egress TLV and NILFEC TLV. Then how we align the FAQ stack and the label stack? So according to RFC 8029, so FAQ stack and the label stack should match. So the number of items should match. So then like so this break it.
See, currently in this case, for the complete label stack, only one NILFEC is sent. Because sending a multiple NILFEC doesn't make any sense, and NILFEC does provide to give the, it can send for the one label and it can send for the multiple labels as per the same RFC 8029. So that is one the answer to the
So
yeah.
my question is, the number of labels and the number of facts should match. So now, like, if you like have
If
to
you use
have
the nil TLV, nil fec sub TLV, that requirement is not how it need to be followed as per the RFC. You
I think unless you change the like RFC like a fact validation procedure, so there's no way to like map one label to two sub fact TLVs.
No, the thing is, Zhang, once the outermost fec stack, like target fec stack is nil fec, you avoid the router doesn't go for the fec stack validation. It just skip the fec stack validation. So there is no
No, so
requirement the label should match with the number of fec.
I don't think you get my point. I think like you mentioned like the procedure only works for ping. If you have trace route, so the RFC defined, you have to have the full fact stack corresponding to the full label stack.
I can point you to the section which tells that it is not. So there is a section on the RFC 8029 4.4.1 FEC stack validation, FEC validation, where it tells clearly if the outermost FEC of the target FEC stack is the nil FEC, then the node must keep the target FEC validation completely.
Okay, it's good at this time to take this discussion on the mailing list.
Offline.
And,
we can discuss on the mailing list.
Provide the reference, Deepti, so that we can follow up on that.
Sure.
Zafar, you're up next.
So thanks. I have similar question like Jay has. So, but I'll come to the rest of the question that I had, which is not covered. So basically, there was some discussion in the context of the generic FACT TLV, and then one of the things that came out of that discussion was we extend the nil FAC with discussing with Shraddha. So we had discussed this in past, and then I think what in the generic FAC draft, what we try to do is we also try to address the agency state, the peer node, peer set states, and flex algo. What would be good is to have that discussion a bit more with the draft authors. So in the context of the SR generic label sub TLV, there is a lot of synergy between the two drafts. They address the goals are similar. We have been talking as well quite a bit on this, and we did discuss this as well, the use of this nil FAC and extender for egress validation. So it'd be good to have that discussion.
Sure, I will be like go for it. Like we can have a discussion maybe on the mailing list or have a call later.
Sure.
Yeah. Thanks, Jeffrey.
Thanks.
Just to answer to Zafar's question, so so NILFEC, the idea is to have a generic way of being able to traverse the data path without having to validate the actual synchronization between control plane and data plane. So if you think of validation at a scale of 1 to 5, the actual FEC validation definition of FEC for each of the SIDs and validation of that stands at 5, the validation level, and the nil FEC based validation stands at 1 because it's not really doing any kind of validation. And I think the generic SID mechanism that you're proposing stands somewhere at 2.5. And yeah, we can have discussion and see
I
what's
agree with Shraddha here.
Yeah.
And the generic SID, there is some validation that is done, not much, but given this, my feedback is, as I mentioned at the beginning, is for the authors of the two drafts to get together, and it's possibly that we end up with a nil FAC extension, going through as well. As Shraddha said, it is data plane validation at the endpoint. Yeah.
Yes, indeed. We did discuss this option in earlier as well with the authors. So sounds good. Thanks.
Okay, thank you. All right. I don't see anyone in the queue, so I'll move on to the next. The next slot is Nagendra. Go ahead.
Yeah, thank you. Hi, I'm Nagendra from Cisco. I'll be presenting this draft on behalf of my co-authors. Next slide. Yeah, so the basic motivation behind this draft, I think we discussed this at least a couple of times in the previous slides or presentations. So with segment routing, we are seeing different types of segment IDs being proposed with different forwarding semantics associated to that. So based on RFC 8029, we go with a one-on-one kind of mapping for each segment ID or a FEC. Will have a new targeted target FEC stack sub-TLB defined, which basically is used to validate the particular FEC. In this case, the segment ID. So this basically requires defining new target FEC stack sub-TLB for each of the segment ID and work on standardizing. So a lot of efforts involved in defining and standardizing. And it also requires either domain-wide or node-wide upgrade, software upgraded, so that the ingress can include the relevant information that is required to be included as part of the targeted FEC stack. And the responder can interpret those information and then send a positive or negative response based on the validation. So this basically raises scalability challenges. Next slide. So this is a partial list of some of the SRFX. We took a stab writing different drafts addressing or defining different target FEC stack for each of these SIDs. And we started realizing that with the plethora of segment IDs being proposed, it may not be scalable to introduce new target FEC stack and have a always on implementation of OEM. So that's why we took one step back and started looking into other ways to see if we can solve this problem. Next slide. So it's not only about standardization efforts required to define and implement these new target FEC, but depending on the volume of information that needs to be carried so that the responder can validate, we basically need a lot of information that may or may not be available in the initiator. For example, the initiator, when it originates the OEM probe, may need to include different types of information that that sometimes even the initiator may not be aware of. And the same goes true with the responder, where the responder need to understand all this information included in the target FEC stack sub-TLB so that it can validate, perform the relevant validation and respond back with the right response. Next slide. So we took a stab of solving this problem by defining a very basic segment ID, which or a very basic targeted FEC stack sub-TLB that only carries the segment ID that needs to be validated. So from the FEC validation procedures point of view, it basically does two things. One is this probe terminating on the right endpoint? In other words, the responder, when it receives the probe, will check two things. One is like, am I the LSP endpoint for the segment ID? And two, did I receive it? Did I receive this probe on the right incoming interface? So by simply using these two validation, we were able to validate quite a few segment IDs. Next slide.
Nagendra, since this is what was presented before, if you can make it quicker.
Yeah, sure.
You had 5 minutes on the agenda.
Okay. So this is the sub-TLB that we defined. As you can see, we just carry only the 20-bit segment ID that needs to be validated. Next slide.
Sure.
So this is an example of how the prefix set can be validated. So we included an example where we have both default algorithm and also a flexible algorithm or FlexAlgo 128. So 16.0008 is the prefix set for algo 0 for node 8 and 16.128 8 for algo 128 for node 8. So when node 1 wants to validate any of these prefix, all it needs to do is include the relevant SID in the as the sub-TLB and send the probe. When node 8 receive it, like I said, it will be performing two validations. One is, am I the LSP endpoint for this SID, and did I receive it on the right incoming interface? So using these two, we were able to identify not just the default, but also any flex algo SID's prefix can be validated. Next slide. So this is an example of parallel SID. From node 7, we have 9378, which is a parallel adjacency SID that could be load balanced between link 1 or link 2 to node 8. Again, if one want to validate 9378, which is the parallel adjacency SID, it simply include 9378 and send the probe. Node 8, when it receives, it checks if it is the LSP endpoint and did I receive it on the right incoming interface. So the incoming interface mapping, we do have a slide that will be explaining about that. But these are the two basic validation that will be done by the egress. Next slide. Yeah, I think we can skip this. Next slide. Okay, so in order to perform this interface validation, did I receive it on the right incoming interface? We basically follow a simple mechanism where each node will maintain all the local segment IDs, like the prefix segment with all the incoming interface as any, and it also includes the adjacency segment IDs assigned by the directly connected next hops to itself. For example, from node 8 point of view, it will include 16.0008 and 16.128.8, which are the prefixes for default algorithm and flex algorithm 128, and it also includes all the adjacency SID assigned only by node 7 for node 8. 9178, 9378, and 9278 are the adjacency SID assigned by 7 for 8. So these are the information that will be included in node 8's table with the relevant incoming interface. For example, 9178 will be marked with the incoming interface of link 1 and 9278 with the incoming interface of link 2. So using this database, any node can, when it receives the probe, will be able to validate if it's the endpoint for that particular SID, and if it received the probe on the right incoming interface. Next slide. Yeah, so in a nutshell, we are defining one targeted FEC stack that is capable of validating multiple segment IDs. So this drastically reduce the the standardization effort that are required, and also drastically reduce the volume of information that is required to be inserted by the initiator and the details that needs to be validated by the responder. So it is also extendable to accommodate any new or future segment IDs. So from the INA point of view, we are requesting one sub TLV from TLV type 1, 16, and 21. We are not introducing any new return codes or return subcodes. We are actually reusing the existing return code and subcode which are defined in 8029 and E287. Next slide. Yeah, so like Tarek was mentioning, we presented this draft in the past in other IETF. So we welcome any comments, and we also request for work group adoption.
Thank you, Nagendra. Anyone in the queue, Nick?
Yes, Greg is first.
Greg?
So if I understood correctly, so you mentioned that each segment, each node supporting segment routing must now add the information about the adjacency SIDs and its immediate neighbors.
Right.
So that does look like a hell of a lot of information additionally has to be stored within the SR domain.
So, like I said, it's not required to maintain all the adjacency segment ID assigned by all the nodes. It's only the adjacency segment ID assigned by the directly connected node for itself. So that's.
I can imagine that will be thousands of immediate neighbors.
Yeah. So you anyway have all those information in the database in your IGP database. So it's either a matter of having it in another database or just reuse the existing IGP database.
Yeah, but that probably needs to be really clearly stated because it's a trade-off. So basically, it's not clear benefits. There are price to be paid.
Yeah. So this is more of an implementation matter. We are not suggesting. This is one of the best practices that you could use to have it as a separate table, but this is not a mandatory table that you're required to have. So if you think that's going to be a overload, the solution still can rely on IGP database to fetch that information. So.
Okay, I don't want to speculate about the implementation, but definitely something to be added to this issue would be helpful.
Okay. Shank, if you can make it quick, please.
Quick question. For the TLFA case, if the packet goes like a protected path, so the packet comes from a different interface, shall we fail the egress validation?
Good question. So if it is an adjacency set and if the link failed and if it is steered over the backup path, okay, we haven't thought about this. I don't think we included anything around this. We can think about this and we can add something in the draft.
Okay, thank you.
All right. Anyone else in the queue? I guess not. I'll move on to the next. Okay, next we have either Yao or Greg. MPLS-based service function path, consistency verification.
Hello, can you hear me?
Yes.
Okay. Hi, I'm Yao from ZT. My presentation is about Mpls-based service function path consistency verification. Next slide, please. Mpls can be used to realize service function paths. So far, there are two methods. One is based on SR service programming, where each service function is related with an Mpls label. Another is defined in IFC 8595, and an Mpls label stack is used to carry the logical presentation of OSH. And the basic unit comprises two labels, and one provides a context within the SFC scope, and the other carries a label to show which service function is to be enacted. And it is called SFC Mpls in this draft for simple. This document defines extensions of the Mpls LSP to support verification between the control management plane and the data plane state for SFC SR and SFC Mpls. Next slide, please. And this draft has been presented on last interim meeting and gets some helpful suggestions from Loa. And here are updates since then. And first, IANA sections, consideration sections has been added for newly defined TLVs. And acronyms section and security consideration section has been added. And the use of the special purpose label in the active OM mechanism for SFC Mpls is introduced in this version. Next slide, please. The new TLVs have been introduced last time, so I'll go through it quickly. First, an SFC validation TLV is defined. If an Mpls echo request or reply contains this TLV, it is an SFC validation message. This TLV contains sub-TLVs only in reply message. Two TLVs are defined separately for SFC SR and SFC Mpls, which is used to carry the SFP detailed information in the reply message. And next slide, please. And this SFC basic unit fact sub-TLV is defined only for SFC Mpls, unlike standard Mpls forwarding, which is based on a single label. In IFC 8595, packet forwarding is based on the basic unit, which is two labels. So the new fact sub-TLV can be used to carry the corresponding fact info of the basic unit. The node that receives an LC ping with a new fax subTLV will check if it is hardy and whether it advertises as service function type. And if the validation is not passed, the node will generate an Mpls echo reply with an error code as defined in 8029. And next slide, please. And this slide introduces using special purpose label in SFC and Mpls. Generally, the packet processing functions supported by service functions are limited. Service functions may not be capable of processing the SFP OM payload and may drop the packet after receiving it. So an service function forwarder needs to identify an OM packet with the SFP scope. And we introduced the use of an special purpose label unit in the basic unit of Mpls label stack for SFC. It allows for a closer functional match between NSH and SFC Mpls. More especially, we mainly discuss about the generic associated channel label. Next slide, please. Mpls generic associated channel is introduced in RFC 5586, and OAM and other control message can be exchanged over it. The generic GL is the generic associated channel label, which is used to differentiate specific packets, like GH packets from others. In this packet, the usage of the GL is expanded. If the GL immediately follows the SFC context label, the packet is recognized as an SFP OAM packet. And below are the processing rules. And so first, an SFF must not pass the OAM packet to local service function instance or SFC proxy. And the next two rules I introduced later. So the next slide, please. In the label swiping mode, there's only one basic unit and one GL in the packet. While in label stacking mode or mix mode, the GL may be present in one or more basic units in an SFP packet, in an SFC Mpls packet. Next slide, please.
Okay, 3 more minutes, please.
Okay, and this is the last slide. And this is a packet processing flow of the service function forwarder. As introduced before, if the SFC context label is followed by a special purpose label, GL, it is recognized as the SFP OAM packet. Then service function forwarder will enter the SPL processing procedure. It decreases the TTL in SF label. And if the TTL is not 0, the OAM packet is processed as defined in 8595. Sent to the next service function forwarder. If the TTL is 0, the OM packet is sent to the local control plane. If the OM packet contains service SFC validation TLV, the service function forwarder will generate a reply message with the SFC info sub-TLV included. If the basic unit fax sub-TLV is introduced, and the service function forwarder will validate the packet as introduced before. And there's an update of RFC 8595, and we in the gray as well. And in RFC 8595, it says if an service function forwarder decrements the TTL to 0, it must discard the packet. And we expect this packet to be sent to the local control plane under certain control to trace service function path. And next slide. And your feedbacks and comments are welcome and much appreciated. Thanks.
Thank you. Anyone in the queue?
No.
Oh, I see someone. Or is it the presenter?
Yeah.
Oh, it's me.
Yeah.
Okay. All right. Okay, thank you so much, Lee. All right, I'll move on to the next presenter. We have one.
Still me. Okay.
Are you presenting as well?
Yeah, I'm presenting this as well.
Oh, okay. Okay, please
Okay,
go
I'll
ahead.
do it quickly. Okay. I'm presenting the draft on behalf of the authors, and this informational draft illustrates the usage of path segment in SR Mpls and Mpls interworking scenario. Next slide, please. The path segment is defined as a new type of segment and has been adopted in Spring Working Group. Path segment is introduced for SR path identification. The path segment will not be popped off until it reaches the egress node of the SR path. It can be used by the egress node for performance measurement, bidirectional path correlation, and end-to-end protection. In SR and Mpls interworking scenario, path segment can also be used to implement these functions. Two scenarios are introduced in this draft: nesting of path segments and stitching of path segments. Next slide, please. These are the updates from last version. The usage of path segments in SR Mpls and Mpls interworking has been clarified. As we mentioned in the previous slide, it can be used for performance measurement, protection, and to achieve bidirectional path. And there are some modifications about the nesting of path segment and the stitching of path segment. And using binding seed to stitch the SR list and LSP across multiple domains is also added. Next slide, please. The nesting of path segments represents end-to-end encapsulation in the packet from an SR Mpls domain to an Mpls domain, which is encapsulated in the ingress node and encapsulated at the egress nodes. The transit nodes are not, and the border nodes of the domains are not aware of the nesting of path ID. And the SR LSP and RPO Mpls LSPs may be stitched across domains with binding seed. Next slide, please. In the stitching of path segments, the SR LSPs and RP Mpls LSPs are established independently in each domain, which consists of seed list or Mpls label. The end-to-end bidirectional path crossing the SR Mpls and Mpls network is split into multiple paths, which can be identified by the corresponding stitching of path segments. The S path IDs will be popped out at the border node in each domain and correlated to the S path ID of next domain. The stitching of path segments can support the end-to-end path stitching and monitoring. And next slide, please. And the authors will continue working on this draft on solutions for the interworking with parking path segments, and comments and discussions are very welcome. That's all. Thanks.
Okay, thank you. I have a question for you. This is Tarek, and my question is: you are creating state at the border nodes, so this is per path state for creating these path segments, right?
Yeah.
Okay, I thought the idea is to not create states on transit nodes in that case in segment routing, but now we're bringing path state into the transit nodes.
That in path segment, most of the nodes have no states, but I think at the border nodes, we can have states for the inter scenario, for the interworking scenario. And for example, like binding seed, it also has states. I think
yeah, but
this
it's not per path.
discuss.
Binding seed is not per path. Here it says it's per path state.
A path state. Yeah, the state is maintained between each path segments.
I'll take my comment offline, no problem.
Okay, thanks.
Thank you. Okay, Kiriti is there. Kiriti, go ahead. Kiriti, do you want to ask a question?
Can you hear me? I'm the presenter for the next, for the last slide deck.
I got it. Okay, thank you. All right, I'll switch over to the next slides then.
Do we have someone else in between? I'm sorry,
yeah,
never mind.
Yeah. The next one I have is for Thomas.
That's right,
Graf.
that's me. Can you hear me?
All right,
Yeah. Okay. Yes, I can hear you, Thomas.
Perfect.
Please.
Thank you. Good. Thomas Graf from Swisscom. I'm presenting the draft export of Mpls SR label type information in IPFix. Next slide, please. So the problem statement is, you see on the right side, this is a packet IPFix packet capture of an Mpls SR implementation. And as you're well aware, Mpls SR is using the existing Mpls data plane, and therefore the IPFix packet capture is more or less identical to Mpls, with one notable difference, which is the Mpls top label type, which is referring to the protocol providing the label. And in this case, it's LDP, even though LDP is not covered in the network. Next slide, please. So looking at IANA into the IPFix Mpls label type registry, we see the problem. Mpls SR is not present there. So currently only the existing routing protocol not covering Mpls SR are listed. Next slide, please. And I received 2 IPFix doctor reviews, and in these doctor reviews, we noticed that currently the registry is not being properly set up. There is a hidden requester section, and actually the column on the reference and the column on the requester is should be vice versa. So in the example below, that's how the registry should be fixed, and I'm currently awaiting feedback from IANA. Next slide, please. I received so far feedback from Spring, Mpls, LSR, and Ops AWG. At IETF 108, I requested adoption at Ops AWG and received feedback in regards to review SR SID type and fix the existing I46 registry, which I just presented before. The SR SID type was removed from the latest version of the draft in favor of the draft Spring SR Young. In section 8.3, there's a nice description basically covering the same aspect. So you can get the same SR SID type information through Young push versus implementing in IPFix. And IPFix has some limitations in terms of packet sizes. And yeah, I'm aiming for do another call for adoption at Ops AWG at IETF 110, and in between, I'm looking forward for receiving feedback from the Mpls working group as well. Thank you.
I have a question for you, Thomas. Just clarification.
Sure. Of course.
Go back. So you dropped the SR SID type. So what's left in that identifies it's a segment routing label?
It's just basically about the label type. So for which label protocol defined the label.
And would I be able to tell the protocol like OSPF, ISIS, or BGP?
Exactly. That's why the IE46 registry is there. It defines which label protocol provided the label.
Okay. Okay, that's good.
Right. The SRC type was more which SID type. So for instance, adjacency SID or prefix SID and so on.
Okay. Yeah. Thank you.
Sure. Welcome.
Any other questions? I don't see anyone in the queue. Okay. Thank you, Thomas.
Thank you.
We have another presentation, but it was supposed to be Jeffrey. I'm not sure if Kiriti, you're filling in for Jeffrey. And if you are, we didn't receive the slides, so I cannot present them.
I think Mark did.
If he did, I can check, but they weren't. Okay, let me see. Oh, okay, cool. No problem.
Slides, yeah.
All right. I'll present them in a minute. And Kiriti, go ahead.
Okay, thanks, and thank you, Mark, for accommodating us on the presentation. So basically, what we're saying here is we have this. We have in IPv6 this mechanism for fragmentation and other functions on packets. For example, inserting an ESP header and such things. So we have the need in non-IP environments to do such things. So we'll give you an example on the next slide. So for example, in EVPN, you get an Ethernet packet from the customer at the PE. And if that packet maybe by itself is bigger than the path MTU, or after you add the MPLS label as the service label as well as the tunnel label, it becomes too big, you can't fragment it. So a workaround is to say, okay, let's do MPLS over IP, so MPLS over UDP or MPLS over GRE, and then fragment the IP packet. But that's a lot of overhead. That's a lot of, it's a much heavier function. Plus, you're not using MPLS in the transport, you're using IP, and maybe you had this nice traffic engineered path that you wanted to use for this EVPN. All that goes out the window. So there are solutions to this in PW. There is an RFC. Many thanks to Stuart for pointing it out. And what it does is put a control word and have some things to indicate the use the sequence numbers to indicate the fragments. Use bits to say this is the first fragment, this is the last fragment, and you can do it that way. But we're looking at a more generic solution, not just for pseudowires, but for EVPN, which doesn't use the control word, but also in principle for other protocols. So maybe peer, maybe MPLS in general. So the thing that we're looking at is to use the IPv6 functions, like for example the fragmentation header. It's relatively independent of IPv6 itself. So the big difference is the identification field for the fragment itself. But so if you already have IPv6 fragmentation in your hardware, maybe it's a relatively small tweak to use it in other contexts. So next slide. So the idea is to use fragmentation reassembly function. So in the case of EVPN, we would say, put the service label and then fragment the packet using, you'll see on the next slide, the generic fragmentation header. And then on top of that, put another label that says fragmentation is next. And then on top of that, put the tunnel label. So the packet would look like tunnel label, GFH label, the fragmentation header, followed by the service label. So the egress PE would see the GFH label, reassemble the packet, and then say, okay, there's more MPLS, oh, this is service label, and then it would know how to hand that off to the right customer because essentially at that point, the service label just tells you which interface you're going out of. Next slide. So what you see here on top is the fragmentation header in a standard IPv6, and below that, how we are suggesting changing it to accommodate fragmentation in other contexts. So IPv6 has this very interesting TLV structure where the T comes from the previous header, and then the L and V are typically in this header. So the previous header would have, or the previous thingy would have said what's coming up next is the fragmentation header. So we don't have that. So we need to do that outside of this. So that's why we have a GFH label that says what comes next is a fragmentation header. The GFH label could be signaled, or it could be a special purpose label, details to be figured out. But essentially, that's how you know that this is a fragmentation header in the payload. The fragmentation header itself, we're starting with this nibble of zeros. This was from a suggestion from Stuart. The next header will then tell you that when you're done with this, you still have MPLS because the service label is going to come up. The header length tells you how to do the identification. Again, in the context of IPv6, the identification is just, for a given packet, you just generate a new identification number. All the fragments will have that same number, and then you put them together. But in the case of if you're not doing IPv6, you may not have enough context just with that 4-byte number, the identification. So you might have to add the source PE, loopback address. You may, depending on if you're doing it for Ethernet, you might want to add a source Ethernet.
I apologize.
Okay, yeah, I'll just take a couple of minutes if you guys can, if Mita couldn't kill us off, which I've been told it doesn't.
Or 2 minutes, that will be great. Thank you. Yeah.
Yeah. So basically, the idea is that you embed a fragmentation header in different protocols in different ways. So in MPLS, you have this generic fragment header label, GFH label, and then you're able to fragment the packet, use the full, use the normal MPLS otherwise, and then at the egress, you can then put it back together. Next slide.
Sure.
So again, this is the description of what's in the header. So I've mostly said all that. So let's go to the next slide. So the idea is then to solve the MPLS EVPN fragmentation problem without incurring the IP overhead or avoiding the MPLS tunnel. But then we could also do it for other things besides fragmentation. So if you want to do ESP or something, you can use an ESP header. Finally, the solution works for MPLS for BR, or hopefully it works for MPLS for BR for Ethernet. Could be used for pseudowires and VPLS. The goal here is just to sort of give you a heads up. We're presenting this, or we've at this point presented this in TSV-WG, BR, and I think we've also presented in BESS. So the idea is to essentially make everyone aware of this, and then find a place to standardize it. So I think the next slide has that. Yeah, so do we find a home in TSV-WG or int area, or that's something that we have to figure out. But we're just putting the idea in front of you guys. We'd love your comments. Thank you, Stuart, for your comments. And yeah, we have work to do, but we will continue discussions. Thank you for the time.
Thank you, Kiriti. We don't have time for too many questions. Stuart, if it is quick, go ahead. I see that you're in the queue.
So I think what the first thing I would say is that putting a type field in MPLS is actually an architectural change to MPLS. And we need a proper discussion about that rather than sort of sneaking it in. I don't mean sneaking it in, but rather than sort of putting it on the back of this draft. So if we separate the type from the actual fragmentation method, we should also seriously consider upgrading RFC 4623 to add the additional field that you need. 4623 is a standards track method of doing fragmentation in this context. So I see two problems, and we should discuss them separately, and we should do the right thing for the MPLS architecture.
So could you explain the type field? Are you talking about the next header, which is in the fragment header, or are you?
Yeah, next header. We've avoided having that in everything else we've done in MPLS by making what follows a function of the bottom label. Oh, those are the top
right.
label.
Or the previous label, yeah.
Yeah.
The thing is, you need to terminate the label stack so that you know that, and so you're sort of terminating the label stack in the middle of the label stack. So you need to come back. So you have the top label, which is the tunnel label. Then you have this GFH label, and then you need to insert the GFH, the fragment header in between, and then you need to go back to the MPLS label. So you're putting a fake end of stack, not really fake, but kind of fake end of stack bit, but you need to go back to the stack.
Well, wait a moment, Kariti. The other guy needs to meet. You need to know the other guy can expect this. So your peer should really issue a label with the instruction.
Which is the GFH label, yeah.
Right. So given that you've got the labels agreed and the capabilities agreed, you don't need to do that.
That's one way of doing it. So when you see a GFH header, you can say whether or not the end of stack bit is set. I'm going to assume that the next few bytes are a fragment header which has a TLV. I mean, it has a length reel, so I know exactly how many bytes they are, and then I go back to MPLS. And that's perfectly good way of doing it.
Right, that is the normal way to do it. Now, if we want to do something different, that's fine, but we need to do that with our eyes open and understand the full set of consequences and why we're making the change. And if we are making the change, are we making the most general change that will serve us into the future?
Thank you, Stewart.
The thing is, if you don't put
Kiriti and Stewart, sorry, are over time.
Okay. We'll take it to the list.
It's actually interesting discussion. It would be beneficial to take it to the list, and we could benefit from your.
Thank you, Stuart.
I apologize. No problem. I hate to cut it here, but we are over time, and apologies. So Jeffrey, let's take it to the list, please. Thank you. All right. Thank you, and see you next time, everybody. Bye.
Bye.
So there's a bug because I can't cut my audio.
So we can continue the discussion until Meet Echo kicks us out.
Right.
So if you don't put the end of stack bit on the GFH label, somebody's going to process this and do ECMP based on everything, treating the 00 nibble field as a label, and that's going to screw up everything. So you put the end of stack bit there. And you're right. If you say that the semantics of a GFH label is that, the end of stack bit is on, but it's only so to prevent ECMP from doing stupid things. And once you've processed it, it is still, it's a fake end of stack bit.
Well, it's not a fake end of stack bit, it's a real end of stack bit because you've agreed to set this logical LSP up between the two peers. I mean, the first thing is that it's a fundamental of MPLS that the two peers understand in advance what's going on.
Yes.
Well, actually, so the next header field in the GFH itself is not MPLS, and the GFH itself is not an MPLS thing.
You created essentially you've created a pseudo wire that's carrying a pseudo wire, I think is what you've done.
No, not like that either. It's really that. So put MPLS on the side for one moment, okay? Forget about MPLS. Let's just say we're doing the fragmentation for Ethernet, okay? without IP, without MPLS at all, just pure Ethernet, pure layer 2. We're doing fragmentation. So we put this we one assigns either type for GF to indicate that the GFH follows, and then after that GFH, the next header value in the GFH will tell you what's coming after the GFH. So now coming back to
wait a minute. Isn't this going across MPLS?
No.
So
we can use this for multiple things.
Right. I'm just using Ethernet as an example to put.
So is Ethernet the bearer, or is Ethernet the thing that's being carried?
The Ethernet is the barrier.
Well, that's an 802 discussion, isn't it?
Right. No. Yeah, it is. I'm just using that as an example to put MPLS on the side for one moment. Okay. So just forget about MPLS. Just imagine, just pretend that we're doing this for Ethernet in IEEE. So we assign either type to indicate that the GFH follows, and then the next header in the GFH will tell what will be the original either type. We imagine that when you're not doing the GFH fragmentation, there is a either type to tell you what's coming after Ethernet header. Now with the GFH, the next header value in the GFH will be the either type. So right now we put MPLS back. We don't have a either type for MPLS. That's why we need a MPLS label to indicate that GFH follows. I think that's what you mean, and that's already designed in this proposal.
No, the way you would normally. Go on.
Well, what I was going to say is, if we did this hack that you suggested for MPLS, then the next header field could be empty, so that we're not sneaking in a protocol type. Although we're not sneaking in a protocol type, we're not saying that because what the protocol people wanted, the people who wanted a protocol type in MPLS, wanted you to say, this is an EVPN packet, it's Ethernet after the MPLS stack, or this an IP, and we're not doing that. We're just saying we broke the label stack into two parts, and we're sort of stitching them back together. But we could say that a GFH label has the well-known semantics that yes, it has an end of stack bit, but there's actually one more label, or there are actually more labels after it. So once you get rid of the GFH header, go back to MPLS, and that's the only thing that you would do. I think that might work. We'll have to look at other situations where we might want to use this in the context of MPLS. And in that case, you'd say, don't use the next header field. But in the case that Jeffrey was talking about, you would need the next header field. Go ahead.
Yeah, so I just think that we've got 20 years of really clean architecture, and it seems to me to be wrong to just change that without huge amounts of thought about the implications and the ramifications. So far, what we would normally do, you've got in the MPLS world, you've got a pseudo wire going between the two points.
Yes.
You decide that you want to have a fragmenting pseudo wire. So normally what you do is you tunnel the pseudo wire over another pseudo wire, wouldn't you?
No, you'd tunnel it over something that you could actually fragment. So you'd normally,
but over a fragment. Supposing we created a fragmenting pseudo wire, which is what essentially a pseudo wire supporting 4623 is. But you say you need this extra identification field, so we could add the identification field in. Now we're completely clean in terms of existing designs and architectures. You create a pseudo wire between these two endpoints. It's got this fragmentation property, and a property of the pseudo wire label is that it says what is underneath. That's the architecture that we've had in place for nearly 20 years, and I'm fine with doing something new if something new is the right thing to do. But if you can do it with the existing, it's almost proved extremely valuable to take a more conservative approach so far.
So here's the thing. The idea is to reuse the fragmentation header, and while the immediate sort of reason for doing this was an EVPN over MPLS case, MPLS doesn't have fragmentation. So if there was a way that we could, do generic fragmentation for MPLS, for Ethernet, for beer, I don't know enough about beer to talk about that, but Jeffrey does, then I think if we would then say we have a generic mechanism. What we need in that generic mechanism is a way to tell the outer thingy, like if it was Ethernet, you use the ether type to say there's a fragmenting header there, and then go back to whatever you're doing. So if you were carrying an ISIS packet over Ethernet, you would have an ether type of ISIS, but you would replace it with a fragmenting thingy, and then you'd put the ISIS ether type in the next header. So we're trying to keep the architecture general so we could use it in multiple cases. The specific case of a pseudowire, we might be able to do something different, but if you wanted to, there was a proposal to do MPLS sec, which is, how do we carry an ESP header in MPLS without actually encoding it inside of IPsec. So I think the idea is to say, is this idea of a fragmenting header or an ESP header or whatever sufficiently interesting to take it out of the IP context and put it in MPLS, put it in Ethernet, put it in beer, maybe, specifically for pseudowires, maybe generally. So that's basically what we're looking at.
Yeah, we've just got a meet echo note.
Yeah, I know.
So I just think this is sufficiently important and sufficiently fundamental that we need a proper, thought process and to decide what we're going to do, because so far we've not needed to do this. But
so far we've had very kludgy solutions to fragmenting MPLS.
Well, except that normally you don't need to fragment MPLS, because normally IP sorts it out for you. I mean, when I say it sorts it out for you, PMTU discovery fails, a packet gets dropped or something, the PMTU discovery runs, and you're back not needing to do the fragmentation again.
I don't think that works for pseudowires, but anyway, we can have this discussion.
IPv6 running over pseudowire will do exactly this. Yes, the IP won't get through, and so it'll say, "Oh, I've got a problem. What I would do is to reduce my MTU." That's how it works.
Yeah,
that's how it's always worked.
Yeah.
And I'm fine with this. What do you mean? It has to work. It's the only way it can work. And no one's complained
Do you actually get an echo reply saying it broke? I mean, you're stuck inside of MPLS.
You inside the pseudowire itself, you won't, but at the pseudowire endpoint. Oh, no, I don't know how this does work. I mean, I've just never complained about it in the 20 years we've been doing this, so it must work.
No, we have, but we've done it by sticking it inside of IP. Anyway, I think we should get off. I don't want the meet echo guys to get mad at us, but I don't disagree with you that we should think through this. I don't think we're trying to sneak a protocol header inside this. We're just trying to say we broke the label stack into two pieces. Please stitch them back together.
Right, and there are lots of other people who've wanted to do that along the years. If we're going to do it, we should do it properly.
Okay, sure.
All right. Okay. Talk to you soon. Enjoy your jet lag or whatever. Take care.
Thank
you.
You too.
Bye bye.